Hello everyone and welcome back to ElectroHobbyTube. I hope you're all having a very Merry Christmas, and today it's been a brilliant Boxing Day. I wanted to explain a few things. I thought with it being the festive season, a great time to build a Christmas tree. I did try to get to do it earlier, but I've had to set up a lot of channels and yes, well, anyway, so I thought let's build a Christmas tree. So this is from Aliexpress. I wanted to explain a few things because of how things work in the electronics industry. What we're going to deal with today is power supply, switch, resistors, capacitors, transistors, LEDs, PCBs, and some information about resistors, just some basics to look at. I'm going to build this tree, 3D tree, three-dimensional tree. I will leave a link in the description box. So if you look at these LEDs, they do pulse 7 colors, which is quite cool. Not your typical LED like RGB or RGBW. They probably have a little micro chip in them, and there's a few different elements to bring about all the different colors. But today we're just going to concentrate on building the tree. So I just wanted to explain about the power supply, how batteries look, or cells, primary cells, secondary cells, rechargeable cells, resistors, different symbols for resistors. We've got different symbols for transistors. These transistors are S9014. They are an NPN, as you can see on the diagram there. Also, there are alternatives to this. There'll be a different part number, but there are also PMPs. And we've got capacitors. Now, I've seen many different diagrams for capacitors over the times. Some people don't circle them, but there you go. You've got the two lines of the different plates. Some are electrolytic with different plates. Some are electrolytic with a dark and white plate. Some are electrolytic and just show a straight and curved plate. But I wanted to explain something that when I've worked in the electronics industry, we used to have square as a ground on the ground plane. Now, depending on your type of PCB, this is just 2-layer front and back. But there is also multi-layer PCBs. But the ground would normally be a square, as far as I can tell on many of the products I've worked on. So I've labeled that on here as positive, which is the anode, because it only describes it as a square where the LEDs go. Okay, and the way LEDs work, emit, so the arrows point outwards, so the light is coming away from the diode, light emitting diode. But like I say, some people, they put a circle around them, some don't. Some describe it as a spoon and cup, or cup and spoon. But you can see here, long leg, anode, cathode. Anode, positive. Cathode, negative. Okay? So just some brief information. Also about the resistors. And if anyone can tell me what we have here. We have resistor values. So you might see that here, there is some resistor values. And how they work. So we've got 10K, brown, black, orange. The third stripe is a multiplier, times 3 zeros. The first two give you the numbers. So brown being 1, black 0, orange 3, times 3, multiply. It's in thousands, so it's K, like kilo, like kilometer. Here we've also got another one, brown, green, brown. 1, 5, 0, ohm. Okay. Here's a list of colours and their values. There is a fourth one on some of the resistors, you'll see. Don't know if you can see that, but you will also find that on some resistors there is a gold stripe. Some can have silver, some can have different colours. But for this one, we'll just keep it simple. Just a small little introduction. Okay? But if you can tell me, don't forget to write in the comments, what is yellow, violet, brown? Can anyone tell me? Okay? Right, let's get building. So I have tested all these LEDs. And as you can see, I did use the battery. So let's get building. Right, time to get seated. And get this soldering iron working. Get the solder ready. Remember, with solder, things that don't go in the body, don't digest. This is solder. It does have lead. Some leads are, they contain like multi-core. They can have flux and other chemicals in them. So always remember to wash your hands, okay? Right, let's get going. 36 LEDs. You may have noticed I made a crimper. Well, not a crimper as such, but something that will hold the LEDs in place. A clamp. Because when I've worked previously on components, you need some kind of spongy clamp to hold them in place. And sometimes it's better to hold them so they're not wiggling all over. So as you can see here, as I made today with a peg, this will hopefully clamp these LEDs in place. Oh, wrong way around. There we go. Oh, look at that. Okay. Now, let's get some solder. Tin one of these legs down. Hey, where are you going? There we go. One. Oh, I need to solder one leg down. Make life easy. Then we can remove the clamp. I did buy all this stuff earlier, but because of time, Christmas, preparing for everything, holidays, everything just got so busy. And then trying to set up the channel, it just took a long time. And then yesterday, when I found out that the original YouTube channel I chose months ago, I couldn't use. So I had to adopt a different thing. And I think littleadam.com wasn't suitable. That was my camera, another one. Just fell over. Now, if you notice, the way I'm putting these in, see, they don't have to be super neat. Though, when I've worked in different places before, there would be a reason that you would. But as this is just a personal project, and I just want to show you how to solder, and how it's easy. Now, look what I'm doing. You won't transfer heat across a point to another point without some kind of medium. So sometimes it's good to put a bit of solder on the iron before you touch the pad, because you don't want to destroy the component overheating it. Now, should have got a little tub for all these little legs I'm cutting off. Preparation, can only do so much, but hey, There we go. We're getting there. A few more. If you like, as I now today, no, this evening, I have been busy preparing and creating new social media for this channel. So feel free to follow me on those channels. I will do my best to keep them all updated. Some of you can tell me where you are in the world, what you're doing today, what have you done this week. All been celebrating the festive season, celebrating Christmas. I know some people this time of year are still out working, keeping the old cogs in the machine turning, looking after the place, looking after the world, the country. So you could always tell me where your locations are. Not your address, obviously, but you could always tell me which country you come from. Feel free to write down in the comments. Oh, they look pretty straight, don't they? Yeah. I haven't got spirit level. Or as we used to say, a man on a horse riding past wouldn't notice. Did I do that one right? No? You trying to catch me out? Oh. Oh, I might make that a little bit longer. There we go. I was thinking to leave them a lot longer and then the LEDs could be moved, but what I also thought was if it gets knocked too much, the legs might snap off. Now I'm not using the clamp anymore because I found I can just hold them in place and straighten them up a little bit later. There we go. Have you all been busy today? What's your plans for next week while you've got the holidays? There we go. Now I am also going to put, I've not put it on here from my player, but I am going to put some nice seasonal music. But I realised that some places, some social media, although it's license free, may choose to pull it. I know a song I was involved in a long time ago got blocked by TikTok. So I've decided that depending on which platform, I'm not going to play music on there directly during the video recording. So tell me, what is your interest in electronics? Where does it stem from? I used to be someone when I was younger, a lot younger, though I've always been messing with LEDs and light bulbs. I mean, some really old light bulbs. I've got some of the old Christmas tree light bulbs. I'm going to get them working. But mine, I've always been interested. My mum, she used to work for IBM, and my dad was an engineer in the Royal Navy. So I've got it in my bones. And then I did in the 90s, I went on a YTS scheme, learning electrical engineering. And it was City and Guilds, long time ago. But what was amazing about it is how much I did learn. I did make a lot of good friends there as well. Not seen them for a long time. But the thing is, what I found is, it gave me an interest. So I had this ability to just, even as a kid, fixing things, creating things, building radio projects, old radio projects. Me and my dad, we had an old project that had valves in it at one time. There we go, there's one side, LEDs. Put that to the side. Next. Yes, I've always been interested in it. I even qualified in electrical installation at one point. But the way things are, it just got difficult. So I decided to work back in the industry, building on the production line. And you'd be surprised, when people have methods, procedures, you learn a lot. I ended up getting more qualifications in surface mount. You see, the thing is, you've got like the old traditional through hole, which is what this is, and then you've got SMD devices, surface mount devices. I enjoyed doing that stuff, using the machines. So I ended up qualifying in actually using the machines at one point, many years ago, over 2 decades ago. And then you've got flow solder machines for through hole. So you would have like a plate of circuit boards get populated, they'll get put on a frame, and then they go across and red hot solder a liquid form as it goes across. It solders all the devices, left to cool, makes the job much faster. Making sure I've got that the right way around. I'm sure there's going to be one of them wrong. Yeah, using optical machines to verify the solder, making sure that components were soldered properly. Other devices to verify connection to components on a through hole and surface mount level. It's been brilliant. And then to actually creating products. And as I moved on during time, making different products for different industries, electronics, electrical. So the thing is, I'm doing this and I'm doing it pretty quick, I think, compared. But it's not all about rushing. I'm just doing it so basically the video isn't too boring for you, but as you can see, this Christmas tree is going to be finished pretty soon. Let's hope it works. Pretty sure it will. Most of the things I've had from Aliexpress have worked quite well, quite fine. I've not had a problem with anything really. And just recently, even though it is around Christmas time, a lot of stuff came pretty quick, within about a week to 2 weeks, which I was surprised. Because some stuff I actually ordered locally, well, London, it took quite a while to get here. Near enough longer. In fact, some cases was longer for some of the presents I ordered. They're from across the waters. But there you go, eh? Like I say, I will put a link to this and the things that I build in the future in the description. Now, somebody I've followed for quite some time, there's a few people really, but I do give a big shout out to bigclive.com. Big inspiration. I've watched a lot of stuff. Some stuff I was just like, wow, I didn't realize. You know? Also, I watch Electroboom. I was going for a different name, but it was too close to his, and that's not fair. And also Zafar Yildiz, if I've said his name correctly, or their name correctly. I love the hobbyists. I love people creating. I know some people speed up the videos, but it's nice to see. If you like things, creativity, inventing. Should show it off. You don't have to get it right every time. It is great if you do, obviously, in your first few videos, but sometimes some things we can plug in at home, they can not work straight out the box. Doesn't mean it's your fault. I remember once getting a waffle maker. I plugged it in, it took the electric out. Blew the fuse. So, not all waffle makers do that, by the way, but this one did. It's a tiny one. But yeah, sometimes we do have some bad luck. That doesn't mean the rest of them were the same. Just me. The one I got. So, you can't blame yourself. And do go easy on the sellers, because sometimes they're just recipients of something that they sell on. So okay, so that's a bunch of LEDs done. That was pretty quick. Let's hope I've done them all the wrong way. We will see. Okay, what's next? What's the flattest thing I can go for? Oh, we'll go for the resistors, I think. Did they actually say where these resistors are? Yeah, 10K, 10K, 10K. Why did we not get any instructions? I wonder. So, on the ground plane, on the base plane, where did I put that? Is there a resistor in there, just randomly? I think that might be our random resistor. No? Okay. Right. So, when this connects together, it's going to look like this. Okay. And there's a few little solder points across. Got to be careful not to short them out. Because as you can see here, we've got a positive and a negative, and in some places it repeats itself, as you can see. Positive line goes all the way up, all the way around, stops at the top, well, near the top. Same there. Negative, but there seems to be a negative up here, so we'll have to check that out. And we also have 10K, 10K. This is going to be fun. What I'm going to do is I'm also going to give you a heads up, because with these kits, this has solder joints joining the boards together. Now, you've got to remember not to throw away the spare or excess cut-offs from the resistors, because we can use them as the joining metal for the PCB. Right, that's one. Now, also when we worked in the industry, we had things for components to straighten the legs. So in my first video, you saw those giant microchips in the IC holders. Wow. When they're manufactured, they're not the shape of the PCB holes, the through holes, or the chip holder. And what happens is you have to straighten the legs. Otherwise, when you go to put the IC and insert it into the socket or onto the board, the legs get bent. So what, we got another 10k there. I believe one of these resistors is going to be an odd one, which is our mystery one. If anyone can answer and tell me what a what yellow, violet, brown equals. Yes, I did put it slightly out of the way of the camera. Probably can't see the colour coding from there, can you? Right, there we go. So then we've got the capacitors, or caps as we call them, resistors. Let's have a look at this one. They should have 3 10Ks as well. Let's see which is the mystery one after. This is going to be a nice tree. I do expect at least one LED to be the wrong way around, have the wrong polarity. But hey, it's Christmas. Where's the beverage? Oh, see that? Didn't push it down properly. Here's a little trick. Well, that didn't go so well, did it? Well, mistakes do happen. See if I can get it now. There we go. You've got to be careful doing that, because if you force while you're heating, you can actually push the opposite side of the through hole solder joint, the actual ring on the PCB. I've seen it happen before. Wasn't me, but here we go. Now, if you want to go super OCD, you can line them up so they're all the same way. It does look pretty, but oh, I think I've found our mystery resistor. That doesn't seem to be over there, does it? No. Alright then. Okay. Now. Oh, done it again. There we go. Yeah, if there's too much heat to the ring on the PCB, what happens is it can disconnect, because not all of them actually have the through hole connector. It's like a little pipe or tunnel that connects this side of the PCB's ring to that side, or square. So they don't have the hole through. Most of them do, because you can tell when you solder, sometimes the solder will flood to the opposite side, as you can see. Great things to understand when PCBs are not correct. Oops, that LED looks a bit wonky there. All right. What have we got? Another 10K. There we go. Nearly done. At least for these bits anyway. Right. It might be easier just to give it a lift before I complete it, soldering it. There we are. Now what have we got? Okay. R6, R4. R6, R4. R2. So is this the main module? So you got R2, R4, R6, R7. 2, 4, 6. I wonder if there is a pattern. Let's have a look where that is in the circuit. That's the bit that goes to the top. Okay, so that's definitely going to be the mystery. Take a wild guess, be confident. If you see a different video after this, you know I was wrong. There's no problem explaining if you are wrong. Remember that. It's the best way to backtrace, to look at an error and correct the error. Now we're on to our 150 ohm. Do you remember the colours? I wonder if you can still see that cardboard with everything on. Here I am asking for answers, and you can probably go, oh, it's still there, it's still on this side of the camera. Maybe I have to crop the video. There we go. Extra legs. Now, one thing I will get into in the future in videos is ESR. So I've worked in quite a few industries, from making safety lights to all sorts, RF, and in some places, I don't know if it's location, but in some places they are very strict on ensuring that you are grounded with a foot strap or a wristband, so you're connected to earth all the time. So if you're touching things like, especially silicon based stuff, microchips, transistors, even apparently LEDs, but some of the more delicate components, what can happen is static that can be built up depending on the type of footwear, clothing, plastic, depending on the type of top you're on. Some of them will actually have an entire grounded sheet when you're working. So, and you'll have a little device that will plug you in to a little wrist strap, and all it does is it takes the static off your body. So if you're touching devices that, you know, are sensitive to static, you don't like destroy them or shorten the life of them. So we will get into that as well. Now, some of them do look a little bit not so straight. Hey, a bit wonky, that one. No, that was. And they're all different sizes. But I was thinking to pull them in different places so they're not all shining up, some shining down. That's why I wanted to keep the legs a bit longer. So, right, here we go. More resistors. So yeah, it is always good for certain types of safety. And also, like I said before in the previous video, you've got to be careful with things that you don't want to digest, especially like lead, flux, solder paste. But it's the same in the house as well, you know. You touch something like the rubbish, the bins, put something in the food waste, wash your hands, you know. It's always good practice. There we go. Right, are they all pretty flat? Yeah. Are they all pretty flat? No. The LCD will be kicking in anytime soon. Sure it is already. Well, you didn't see the table when I started, did you? I laid out all the LEDs, tested them all. There we go. Right. Now we've got 3 caps. 3 transistors. Now, like I said in the previous video about transistors, these devices. Now, you can get 2 transistors, 2 capacitors, 2 resistors, 2 LEDs, and you can create something that flashes back and forth between 2 LEDs. An instability, or should I say, the tolerance to different components can trigger the first side. So what you'll get is 2 LEDs flashing on and off. Now, what we've got here is each one of these PCBs, or sides of the tree, they're going to have 3 transistors. Now, I have made a device like this before when I've worked on markets, and I made a little set of LEDs, little chaser LEDs. And what would happen is one part of the circuit would set off and jump to the next, and it would do this. But every so often, it would have an issue, because depending on tolerances, charge of the capacitor, you would end up with it stalling, and you get 2 LEDs kind of stuck on, and it wouldn't flash. It kind of cancelled itself out. Could have been a faulty connection, who knows, but it seemed very strange. Now, when I looked at this circuit earlier, I didn't go through the whole thing, but it looks like one transistor feeds the other 2 transistors. So I'm just straightening stuff up and making sure these LEDs are aligned and flat down to the PCB. Not ruin that solder of it. Nope. Right. Okay. So we'll finish these off. Now, if for some reason part of this circuit doesn't work, I'm probably going to look more at that resistor I've kind of put in R7, because it's possible that might cause the circuit not to function correctly, but it might just work amazingly. Let's see. Like I say, this video isn't more about the teaching, just a little bit of an introduction and a little bit of knowledge, some symbols, learning about different components at the basic level, and different diagrams you might come across when you come across projects of your own. There we go. Yes. Can be a little bit wonky. That's good. That's that. Let's have a look at that. See, I'm quite happy for this to not just point in a line, but be all over and point different ways. So when the LEDs light up, some can be up, or some can be that way, some can point down, some can point upwards. So it gives a nice little array of light. Right. Which is the thinnest components and which way they're lying down. Okay. I will say, let's get the capacitors in. Now, what I'm going to do, something we used to do in the industry, I don't like folding capacitors right on the point of where they actually insert into the capacitor, because that can break the legs off on the component. So I don't mind, they can be a little bit longer. I used to have a device that would bend them, but I'm quite happy with that. Now, where's the clamp? Yeah, I have. It's also good to leave, if it's a little project of your own, leave a little bit of leg room. Just so, if something needs to be done with a component, or maybe you want to change it out. See, with the capacitors, they actually control the charging time, the flicker time, the flash between triggering the transistors. So you could swap them out for a smaller capacitor or a larger one. And what would happen is, let's just see, yeah. What would happen is the tree would change. Now, depending which one is the main capacitor, we won't know that, but at this point, but you could probably swap it out or swap them out for variables, depending if you can match the value. You can make them fit the footprint of the component, and you can change the speed of it. There we go. Oh, I think the heating's coming on. I just heard a creak. Hey, turn that around. There we go. Yes, do remember, don't hold your soldering iron with solder onto a component for ages, because you will most likely burn it out. Now, look at the footprint for these transistors and look at the footprint. See? So what would be a good idea is not to allow the legs to get broken. Do be aware of that. This is one of the problems that can happen, is you fit them too tight and you end up with trying to order more components because they broke. You see, that would be more ideal. Oh, don't want to short. That's what happens when you solder two things too close together. There we go. Now, how's that look? Not too bad. Yes, there are things you can buy to set the legs, the distances. But for little projects like this, it's okay. But in the future, like I say, we'll go through electrostatic discharge, because as we get into more sensitive projects, we don't want to make a component fail or have a shorter life because we've potentially ruined it or destroyed it through static buildup, either on our bodies or in the location that we are. Sometimes we used to have old televisions, the big CRT tubes, cathode ray tubes. You could walk up when they were turning on, a little glow in the middle of the screen. You would get a lot of static come off them. In fact, you could get static quite a lot because the amount of voltage that was in them. So here we go. I think they worked around on some of the bigger TVs, 20 to 25 volts on the power supply unit. Giant capacitors. They came with their own power supplies. On some of the televisions you could be swapping those parts out, the whole thing. Nowadays they're much simpler, but they're not as easy to fix. Simpler as in they take up less space, use less energy, are better picture by far, but they're not as easy to fix if you don't understand electronics. In fact, sometimes it's probably cheaper and easier just to replace the television, depending on what the fault is. But that's why I like YouTube. Because YouTube has lots of videos on how to do many things, many crafts, even how to start up your own YouTube channel. See, I cheated there. I got 2 pins for 1 solder. Yeah. Right, okay. The last transistor. Then we're on to the last 3 capacitors. I did that back to front, didn't I? Oh, I wonder if that'll be in your comments. Can't wait to see. I'm going to try and get this uploaded, if I can, before midnight. What time is it? Yeah. Ooh. Maybe not. This might be a late video. It's 25 to 12. Hey, come on. Right. There we go. And just 3 capacitors. Okay. So, positive. Good job to have a clamp. Yes, this is just clothes pegs for the washing line. I made it earlier because I thought I might struggle trying to get these LEDs in place. Nope, wasn't that bad. Yeah. What's next? Capacitor, that way around. Yes, if there's any kits or anything or something you'd like to see me build, please put a comment down in the bottom and I will, down in the comment space, and I will see if I can get hold of it. I have bought over probably, let's say about a year, lots of little kits, lots of things to build. Some of them are quite simple and quick. Some of them are quite hard. I know that rotating clock, persistence of vision. Now that is going to be a beast. But I did buy, by accident, a few Tesla coils in the circuits because I got 2 tubes, but in December I accidentally bought an extra Tesla coil. And ages ago, years ago, I thought I'd actually bought the circuit and just bought the coil, and I've got a massive coil, bigger than what's for the kit, so who knows? Here we go. Now, positive, positive, negative, negative. Right. There we go. Transistor alignment. Let's see if we can do it that way. Oh, capacitor alignment. There we go. Wow, they are close. Too close. Yeah, that's not too bad. Alright. Okay. Now we want to line these up. So there's no circuits there, is there? No. Right, let's take one of these LED legs. Wait, where are you going? Bend that, bend that. Now, they don't need to be perfect, as in, as long as they're pretty tight to the footprint, we should be able to. Oh, might be that, like that, is it? Let's see if we can get that to work. That's a little bit tricky. That's fine. Now, if I'm right, I don't need to solder all of them. I do need to try and make sure that it's square to its shape. There we go. Ah, look at that. There we go. Make sure we cut the excess off so we don't short anything out. Now, does this have... It does, it's just one LED. It's not 4 2. We could get 2 in there, I suppose. There we go. Now, clamp. There we go. So that is all LEDs. I was thinking to put 2 there. Maybe I'll alter it in the future, but now pull that across there. Strain that up. Could put a little branch there, but for now it's just together, which is great. Now what I would say is, before putting the tree in there, let's look what other components we need to fit. Now this has location pins, which are there, and 3 pins. Now with some of these sockets, they put 3 pins, so if you decide that you want to connect batteries, but you have a power supply cable, one of these pins disconnects the batteries, so you're not running the power supply directly into the batteries first, for safety. We'll see how that works. Okay, now that's the socket. I could connect the batteries, why not? They are some mega long wires. Wow, okay. What's where? Right. And that is maybe better that way. They don't align up, do they, very well? Maybe I'll just cut that a little bit excessively longer. pointy thin cable that was. Still is. And here. There we go. I always tin my wires just to make sure. Oh, it didn't look like it tinned very well. That's fine. That'll get snipped off. Yeah, some wire, some of these some cables, depending, might need to be fluxed first. Some wires, depending on like whether it's copper or it's coated, some of them won't actually take the solder very well, and you'll end up, while you're trying to heat the wire, the insulation starts to degrade and burn and change color and starts to smell. It's not good to breathe that in. So I would say if I was doing this all the time, I would have what is like an air extractor, because the smoke, you see, some of the fumes, if there's too much, it can be bad for breathing in, depending especially what type of solder you've got. Now there's the base. I'm glad I left that extra excess of wire. Now positive, positive, negative, negative. It looks like it's there. Oh, was. Yes, fidgety. Okay. I don't know if you can see that, but I am just making a one-sided connection. Don't need to flow it with too much solder. I say that, but never know. Just in case. Right, okay. Now, go grab a power supply. A power bank. So I have what is power bank when I used to work outside. I used to work in the woods. Now, let's see. Put that in there. Plug that in there. What do we get? Nothing. What have I done wrong? Done that. Done that. Shall we try some batteries? See if the batteries work. No. Now, let's have a look at this. That's negative. All the capacitors are in the right place. Transistors are in the right place. Let's have a look. See what's wrong. It would be a shame if this is back to front and all the LEDs are... Oh, of course. Did anyone spot the mistake? No? What if I get to put in the switch? If I check that this functions. Well, isn't that strange? Okay. Right, there is obviously a circuit error. We'll have to see where that is. Something not soldered, something in the wrong place. So we've got negative, negative, positive, positive. This could just be a solder issue. Does look like it is a solder issue. And sometimes what you can get with solder, if it hasn't heated through, you can get something called a dry joint. And this is what's good about being able to fix and repair things, so understanding fault finding. Let's see what this does. Oh wow. No LEDs are off. As far as I can tell, no. That's good. Right, I'll turn that off. And we'll just give that a flick. There we go. So what I've done is I've just cheated the 6 pins on this switch, and I've decided that I'll just bend a couple for the sake of being able to solder. There we go. So is that now reversed? No, it's just short circuit. There we go. Right. So we have ourselves a nice little tree. There we go. You see how that works? Now, like I said about having the LEDs, you can have them point in different directions. You could have some point up as long as you don't break the legs on the LED. But you get a wider variety of light if you put them in different directions. So you're not just having the light in one line. Now what I'm going to do is I'm going to turn off these big bright lights so you can see what it is. So just be careful. I'll just show you what this looks like. Very nice. Okay, I'm putting the light back on. There we are. Okay, well, I hope you've enjoyed this video. Please remember to like and subscribe, and if you like, you can share my content. I am more than happy for you to join me on this journey of building electronic kits, and I build all sorts. But I will be teaching about Ohm's law. I will be showing more in-depth things about LEDs, how they work, maybe boring or not, how negative and positive devices work. So some, like transistors, LEDs, silicon devices, some of them have got, like, they're doped with like a negative and a positive, and that's how they work, so the reactions. But things like LEDs, they've got like they've got different stuff inside them, and that's what gives the different light. So some of the first LEDs you probably ever saw, going back decades, were red, and then I think it was green, and then yellow, and then the other colours came, especially when they found blue, and then we've got green and like white, you know. But we'll get into that in the future videos. Thank you for joining me. I hope you've had a brilliant Boxing Day. I know it's going to be the 27th by the time as this video comes out, but please enjoy your holidays. I hope you relax, and thank you very much for joining me. Bye bye.